Hello guys, welcome back to my video. In this video I'm going to talk about sampling techniques. So as all of my videos follows, this video I'm going to teach you from basics. So let's understand what is sampling and what is a sample in the first place. So first things first, let's talk about population, and which is a relative term to sample. So population is nothing but all of the data points that we have. So in academic purposes, we would be just using like observations having max to max 10,000 to 20,000, but in real world you would be having around 200,000, 300,000 of observations, which is often referred as uh, the whole database. However, uh, there is ton of information out there, right? It's always lesser than whatever is available in the world. So let's see this with a simple example. Let's consider the whole population of the world, and you are trying to calculate what is the uh, average income of the whole world, which is like calculating is simply impossible, right? You can't go to each and every person. Even if you go to each and every person, it's gonna take ton of time, right? So for this, you will try to pick some random people from each country, and you will try to do average or whatever. I know it's a very exaggerated example, but still that's the case. So that is the whole point of doing sampling. Okay, you're trying to get the information of population by picking some few data points and calculating the statistics. So that is called sample. So it's by definition it is referred as subset of a data from a larger population. So what, as I said, sample is trying to estimate the population parameters. Instead of going to each and every person in the population, we will try to pick some few people and go it from there, right? So that is the purpose of a sample. And also there are few things that we need to remember while doing sampling. So we got to make sure that the bias should be handled, and also we got to ensure it represents the whole population. So by doing that, it simply increases our efficiency, right? We need not go to each and every person. So what do I mean by bias? So for instance, I pick only people. Oh, sorry. So for instance, I'm trying to calculate the average weight. For instance, let's say all this is the population and I'm trying to calculate the average weight. So I pick all women's, mostly women's, and I don't pick men from the population. Then what happens? The average weight would be less than the actual population, right? Because like men's usually weigh more than the women. So we got to make sure bias has been addressed. Bias is nothing but showing some particular favor to subset of audience, like rich, for instance, let's say I could say rich people, and uh, sex, like male, female, and stuff like that. So we got to make sure there won't be any, like bias in the population. So a ideal, ideal sample represents the whole population, tries to represent the whole population somehow. So for this, there are few techniques to do that. So there are few techniques. Some of them are simple random sampling, stratified sampling, systematic sampling, cluster sampling, and multi-stage sampling. I'll try to explain this in two liners so it would be easy for you and you can go it from there. Okay, first let's talk about simple random sampling. So simple random sampling is nothing but all of these come under probabilistic sampling. Okay, uh, so simple random sampling is nothing but the name says it. So everyone has an equal chance of getting picked. Okay, so for instance, let's say there are 100 people and each one has 1 by 100 possibility of getting picked up. So We don't know, like we can pick this guy, this guy, this guy, this guy. It all depends on so randomness. Computer tries to assign few random numbers and we'll try to pick it from there, just like a lottery. That's it in simple terms. So whereas in the other techniques, simple random sampling is simple as such, and stratified sampling. Okay, in simple random sampling, what is missing in simple random sampling? Let's start from there. So what if unexpectedly uh, my computer just picks rich people? Like it's random, right? Even though that's a possibility. Or else my system gives more weightage to rich people, or else the other class. Some it tries to take some class, give some more weightage to class unexpectedly. Things can happen, right? It's all probability. We can do the math. So to avoid that, to ensure that all of the groups have been addressed, we'll try to create few stratas. For instance, let me take this example of sex. We'll try to divide this population into two stratas. Strata is nothing but group, male and female, and we'll try to ensure that, for instance, let's say I'm picking 20 observations to the sample, so I'll make sure that 10 samples come from male, 10 samples come from female. I mean, like 10 observations and 10 observations from both the groups. So in such way, my sample has represents both of the groups in equal ways. So that is the whole purpose of stratified sampling. So which is a very important case in a lot of research studies. We got to ensure that all of the people have been addressed. So uh, this technique is a very important one. So uh, I would like to tell people that it's very important to know this. And stratified sampling is done, and systematic sampling is nothing but it's very simple. For instance, let's say there are 5 people in my population and I'm trying to pick 2 people. So we'll come up with some kind of number, k. So k represents, let's say for instance I am trying to assign a number for k, let's say 2. So every second person that I meet while going through population, it'll be picked into my sample, just like this: 1 2, hey, you are inside my sample, okay, good. This guy goes inside, and again 1 2, okay, then you can go into the sample. In the similar way, I'll try to pick these 2 people. So that is the whole rule. It's a systematic sampling. So it ensures that not everything is random. It decreases the random percentage. Okay. And coming to cluster sampling is nothing but, so for instance, let's say uh, all of these are students. Okay, all of these are students from all the schools, from all the schools in the world. Okay, and I'm trying to pick few students. So there are few techniques that I mentioned, which are simple random sampling, stratified sampling. Now we are talking about cluster sampling. In cluster sampling, what we do is we cluster all of these people into groups. Okay, into clusters. So cluster is nothing but all these 3 people in one group, all these 3 people in one group. In simple terms, I can say uh, schools. Okay, school A, school B, school C, school D, and in a similar way, all of the schools will be listed, and I'll simply pick one school and consider that as my sample. Okay, as simple as that. Or else, like speaking of countries, I'll randomly pick one country and take everyone in from that country into my sample. Like for instance, I can list down all the country names and pick one country, let's say it's Russia, and pick all the people from Russia into my statistic. Okay, so that is cluster sampling. Coming to the last one, multi-stage sampling. Multi-stage sampling is an interesting one. So it is nothing but combination of these samples. So for instance, I'm just making this up, but there is no like particular way of doing this multi-stage sampling. So first I use cluster sampling. Okay, so as I said, like I just picked Russia, right? So in Russia, I'm doing sampling. Then next I would ensure that all of particular groups have been taken into consideration. For instance, category of sex. Okay, so for that, first step I would be using cluster sampling. Second, I would be using stratified sampling to make sure that all of the groups have been equally represented into my sample. So that's how all these sampling techniques works. Remember the end goal. I always remember the end goal. You're trying to replicate the properties of the population. For instance, let's say the average age of all the population is like 35, and we got to somehow match this. Our sample needs to make sure that uh, the average age of the sample would be around 30 to 40, so that it is like close to the population. So that is the whole point. Okay, try to always, in any kind of statistics or anything that you do in machine learning, always try to remember the end goal and stick to the basics. So that is a small suggestion that I would like